It's a beautiful meme. Okay. Yikes. Okay, so, and we're live.
Should I ask if he's okay?
Probably. We'll do it later. All right, so, first one we're going to skip. I'm going to look at the second one. I'm going to pick C to C prime. Remember, translations are just vectors. And vectors, when we apply them, apply to everything. So if I find the vector that's going from C to C prime, it's going to be the same thing as D to D prime, B to B prime, A to A prime. It's going to be the same one, right? It's all going to be the same. And that's going to be our rule. So if you look at C, its coordinates are negative 1, 2, 3, 4, 5, 6, 7, 8, comma 1. And C prime is 1, 4. Now the question is, what did I do to get from there to there? Negative 8 plus 9 gets me to 1. So adding 9 to the x got me there. And 1 going to 4, well, I added 3. So that's my rule. And if you look, that vector that I drew, its components are 9, 3. I'm going to the right 3. Or I'm sorry, right 9. It's a big 3. So the right 9 and up 3. So those are the components of my vector. So two ways to do it. One, write your coordinates down and see what you do, right? I added 9, I added 3. Plus 9 gets me there, plus 3 gets me there. So there's my rule. Or, draw your vector, figure out how far you went over and up. That's all this is, right? How far we're sliding them. We slid C 9 to the right and 3 up. How you feel, Corinne? You ever seen the Robin Williams movie, Patch Adams? All right, I watched it last night. Not a great film, but again, it's Robin Williams' catalog, so I got to watch all of it eventually, right? Watched it last night. Main role in that one for the female lead, she plays a character named Corinne. She acts just like you. She has the same like facial expressions and the same voice. It's crazy. I was like, ha, that reminds me of Corinne. And then her name was Corinne in the film, and I was like, oh my god.
Is it spelled the same?
No, not at all. And it's based on a true story. But have you ever watched the show Parenthood?
No.
Okay, the blonde one, the blonde daughter in Parenthood, it's that actress that plays her. So many coincidences. Anyway, reminded me of you. Very deadpan delivery. I have no soul, right? And I was like, ha, that reminds me of Corinne. And then that was her name. Questions on this? No? Easy peasy, lemon squeezy? So if I asked you to do number 1, what would the vector be? What would the rule be for number 1? 0, you said 0. And then what? 8. Somebody else, explain why the rule would be 0, 8. Alex.
They stay in the same place with the x value and that's up 8.
Yeah, so if you look at B to B prime, do we go left or right any? No, we don't. So 0 in the x direction. However, direction matters. We're going towards prime. B to B prime, is that a plus 8 or a minus 8? Got him. Direction matters. We go towards prime, right? Again, you could have checked the coordinates. B's coordinates are 0, 1, 2, 3, 4, 5, 6, 7, 8. And B prime's coordinates are 0, 0, right? So what did I do? I added nothing to the first one, and I added subtracted 8 to the second one, yeah? How we feel? Excellent, wonderful, fantastic. Ava, how's it going?
Good.
Fantastic. What did you do this weekend?
Work.
Where do you work? Where?
Rest at.
Oh, yeah, right, rest have. I forgot. Was it restful? I wouldn't expect it to be. You do important work. Turn the page. Let's take a gander at number 4. We're reflecting this guy. Now, you know as well as I know, when I look in the mirror, mirror me is just as far away from the mirror as I am. If I move close to the mirror, mirror me moves closer, and vice versa, right? So, here's me. I'm a line segment. And here's the mirror. The line segment is 5 away from the mirror, yeah? So it's going to be 5 away on the other side. And there's B prime. Same thing for A. There they are. Now, when I reflect over this line, am I reflecting vertically or horizontally? What am I doing? Vertical, right? A vertical flip. Which variable deals with the vertical? X or Y? Y. So our Y value is what changes because we're doing a vertical flip. So negative Y, keep the X. And that makes sense. If you look here, B is 5, 5. And B prime is 5, negative 5. So do you see how I kept the X and changed the Y? Remember that negative sign there doesn't mean make it negative. It means change the sign. So it was positive. Now it's negative. X didn't change. Y did. Vertical flip. Number 5. Is that going to be a vertical flip or a horizontal flip? Horizontal flip. It's flipping this way. Can I show number 5 now? Cool. It's a horizontal flip, yeah? So what's going to change, the X value or the Y value? The X value. And if you look, that makes sense, because here's C. It's 3 away from the line of reflection, right? 3 to the left. It's going to be 3 to the right after we flip it. C's coordinates are negative 3, positive 2. And C's prime coordinates are 3, 2. So Y stayed the same, and the negative 3 became a positive 3. So X's sign changed. Remember, when we negate something, it doesn't mean make it negative. It means change the sign, right? Negative 3 negated is positive 3, right? Negative times a negative is what's going on there. That's positive. And that works for all your variables, or all your coordinates, I should say. Second time I've done that today. All right, 6 gets weird. First off, what kind of a flip is it going to be? Horizontal or vertical?
Horizontal.
The line is vertical, but we're flipping across it, right? So it's going to be a horizontal flip. Okay, so it's going to be like this one, right? Number 5. Same direction that it's flipping in. Now we know a mirror works this way. If I'm 5 feet from the mirror, mirror me is 5 feet away. So here's A. Look how far it is away from the line of reflection. 3, right? So when I flip it, it's going to be 3 away as well. Well, D's already in its spot, which, is annoying, but it's fine. A prime's just going to go there. Also, if you notice, D is also 3 away from the line of reflection. So when I flip it, it's going to be in A's spot after I flip it. Just a coincidence. Sometimes that happens, right? For example, this up here. Look at the red rectangle. Here's the purple line of reflection. B is 2 away from the line of reflection. So after I flip it, it's still going to be 2 away. It's going to be here, right? Yeah, that's the line of reflection. But when you count coordinates, you count it from the origin, right? Okay, cool. Back here. B is 2 away from the line of reflection. So when I flip it, it's still 2. Do you see how B and C didn't switch spots here? Right? That was just a coincidence over there. 2 and 2. C is 8 away from the line of reflection, so when I flip it, it's 8 away on this side, right? So sometimes they trade spots and sometimes they don't. For there, it was just a coincidence because they were both 3 away from the line of reflection. So when I flip this red image, it's going to be to this blue image. Because the line of reflection isn't down the middle, right? It's a little lopsided. Here, it's perfectly down the middle, so things are going to trade spots. So let's write down these coordinates. Figuring out the rules is going to be a little more difficult, but we can handle it. A's coordinates, original A, again, we count from the origin. This is going to be a mistake you make tomorrow, so make sure you look. I guarantee when you guys go to count A to figure out its coordinates, you'll start here, and you'll go 1, 2, 3 to the right, and 5 up. Why is that wrong? Why is it negative 2, Eads? Here's the origin. A lot of you guys are going to see that big thick line and start there. That's the line of reflection. To figure out its coordinates, we got to start at the origin. Here's the origin. So negative 2, positive 5. Don't let that mistake happen to you. Double check your coordinates. A prime, again, starting from the origin. 1, 2, 3, 4, up 5. Who, when they were counting for A prime, counted from the line of reflection? Who did it? There's always one. There's at least one. I do it every single time. Thank you, Alex. Hannah did it last class. Happens to the best of us. Make sure you count from the origin. 4, 5. D, also 4, 5. And D prime is negative 2, 5. So now let's look at these for the rule. Gentlemen that are running ahead, I bet you guys said that you keep the y and that you either times by negative 2 or add 6. Did you did you say either of those? You say add 6? Did you say times by negative 2? Okay, because if you did, you'd be wrong, because look down here. If I add 6 to 4, do I get negative 2? If I times by negative 2, do I get negative 2? No. So it only works for the top. We do keep the y, right? The 5 always stays. That works for all the coordinates. But the x is going to be different. So here's what's happening. We start out with our regular coordinates, right? X, y. What kind of a flip are we doing? Horizontal or vertical? Horizontal, which means we're going to change the x. Cool? Now, this assumes we're flipping over the y-axis, like we were on number 5. Like this one, see how the line of reflection is the y-axis? Makes it nice and easy. This one's a little off-center. So it's not going to be this for the rule, but it's going to be something like that. Look at D. D is 4 away from the y-axis. So if I were to do this rule, which says flip it over the y-axis, right? It would end up 4 away on this side. 1, 2, 3, 4. So D prime would end up here instead of here. How far is D prime, the blue one, from the pink one? How far are they off? How far would they be off by? Right here. 2, right? Same thing for A. A is 3 away from our, 2 away from our line, our y-axis. If I were to flip it over there, it'd be 2 away here. And it would be 2 off of where it needs to go. So here's what we're going to do. We're going to apply that flip and negate the x, but then we're going to add 2. And that's going to be our rule. Alex.
I'm confused. If D prime is supposed to be on 2, why is it on negative 4?
Hold that thought. So we know it's a horizontal flip, right? And we know horizontal flips do this, right? Negative x, positive y. Are you cool with that? Horizontal flip changes the x, right? Because it's horizontal. X is horizontal. So here's how I want you to think about it. You know it has to flip. This sign has to change. Because you know you're going to do negative x, positive y, right? Are we cool? Then you need to ask yourself, after I apply that flip, how do I get from here to here? So Alex, looking at these numbers, what do I do to get from there to there? I add how much? 2. I add 2. So negate it, and then add 2. That's the rule. Why are we negating it? Because we know it's a horizontal flip. We have to negate the x. That's what it says up here, right? But we have to do a little bit extra because this line's moved. And that little bit extra is whatever it takes to get from here to here. And that's to add 2. Let's try this again. Let's look at B. Here's B. B prime. Well, B is 3 away from our line of reflection. So it's going to be 3 away on this side. Again, it's going to change spots with C. So that's where B prime is going to go. Is everybody cool with that? Okay. So let's write down those coordinates. B from the origin, negative 2, 1. Again, not from the line of reflection, from the origin, negative 2, 1. B prime from the origin is 4, 1. So let's look at these coordinates. We know we're doing a horizontal flip, right? Horizontal flip means we negate the x or negate the y. Which one? Negate the x, because x is horizontal. So step 1 is to change that first guy's sign. Now what do I do, Alex, to go from 2 to 4? Add 2. So I must negate and then add 2. That's the rule. How do we feel about that? Apply your flip like you would for any other, and then figure out what you got to do next, right? Do I add 2? Do I add 3? What do I do? Well, in this case, I add 2. Yeah.
Can you use D again?
So I look at D. Here's D and here's D prime. We cool with that? 4, negative 2? 4, 5, negative 2, 5? I know it's a horizontal flip. Horizontal is the x value, so I negate the x. And I get this. What do I need to do to get from negative 4 to negative 2? I add 2. So I negate the x. That's what this step is. And then get from there to there, I add 2. Did the y ever change? No. So it's negative x plus 2, comma y.
I'm so confused why it's on negative 4 on graph.
This is wrong. The reason the thing I did in blue, I was trying to show that what this first move does here when you just negate it, it assumes you're flipping it across the y-axis. If we did that, it would have ended up there. And then that plus 2 kind of corrects it. That's why this is what it is. Okay? Whenever we just do a regular negation, it assumes flipping it over the y-axis, even though that's not what we wanted. And so to make up for that, we had to slide it over 2. Plus 2. Good question. Does everybody see how we can write the coordinates down and figure out the rule? We know it's a horizontal flip, so we got to negate the x. And then we have to ask, how do we get from there to there? In this case, add 2. I'm going to do an example that's not on here. Here's a coordinate plane. Here's my line of reflection in blue. Here's my point, my original point. Let's call it A. And I want to flip it across that line. Which way am I flipping the point? Horizontal or vertical flip? What kind of a flip will this be if I flip it over that line? Horizontal, right? It's going this way. Horizontal flip means I negate the x, keep the y. However, that assumes this is our line of reflection, and it ain't. So let's figure out where A prime is going to be. How far is A from our line of reflection? How far is it from the mirror? It's 4 away, right? So if we mirror it, it's going to be 4 away on the other side, right? So here's A prime. Right there. Let's write our coordinates down. Looks like A was originally negative 2, 1, 2, 3, 4, 5. And after we flip it, A prime is from the origin 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So what happened here? We didn't just change the x, right? That doesn't get us the win. But that's the first step. We do want to change the x because we're flipping horizontally. So our first step is to write it like this. Change the x, keep the y. And then we have to ask ourselves, what did we do to the 2 to get to 6? How much do we have to add? We add 4. And that gets us here. So what did we do? We negated the x, we changed its sign, and then we added 4. Did we change the y at all? Nope, so just regular y. How do we feel about that? We know it's a horizontal flip, so we change the x, but that's not enough to get the job done, right? We got to get to 6. So we have to add 4 on top. Are we cool with that? One more. Alex, don't answer any of my questions this time. Somebody else. Here's our coordinate plane. Here's my line of reflection. Here's the point I want to flip. Where'd my green go? First of all, what kind of flip is this? Vertical flip. So that means we're typically going to do something like this, right? Change the y, keep the x. Right? That's what a normal flip would be. But that's when you flip it across the x-axis. This isn't the x-axis. It's close, but it's not quite, right? We know that A is going to flip to here because it's the same side on both sides of the mirror, right? It's the same distance, I should say, on both sides of the mirror. A's coordinates are -2, 3. And A prime's coordinates are -2, 1. Okay, so we know we have to apply this rule, right? We got to negate the y. And then what do we have to do to get to 1? We have to add what? We have to add 4. So we negated the y, and then we added 4. That's our rule. Feeling okay? Do we see why we have to negate the y because it's a vertical flip? Okay, awesome. And then 4 plus -3 is going to get us 1. So that must be the thing we have to add. Okay. So you know this because it's a vertical flip, and then you have to ask yourself, okay, now what do I do, right? Add 4. But you have to know this so you can get to there. If you know this, you're almost there. All right, rotations. Thing we did the other day. Number 7. I'm only going to do a couple. This is when it's centered on the origin, right? R is on 0, 0. We're going to draw our L between R and one of our points. I'm going to do B. So here's my L. Everybody cool with that? So focusing on the blue line. Blue line is pointing to your left, correct? I'm going to turn it 180 degrees. Now, if I turn it 180, does it matter which direction I go? If I go clockwise, I end up in the same spot as if I had gone counterclockwise, right? So it doesn't matter which direction. That's why I don't specify. So let's turn it 180 degrees. I'm going to go this way. 90, 180. If I'm pointing, if I was pointing this way, now I'm pointing that way. What direction is this? To the left. My left. I'm sorry. My left, your right. So it's to the right. Thank you, Corinne. Sorry, guys. Your right, my left. So it's going to go to the right. So there's our line. It's 1, 2, 3, 4, 5, 6 in length. So instead of going to the left, like we were originally, we're going to turn that 180, and it's going to go to the right. Still 6 in length. Now I need to figure out that red part, right? Well, the red part's pointing up. If I turn that 180 degrees, which direction is it going to point now? Down, right? It was 3, so it's just going to go from that end, 3 down. And there's B prime. Cool about that rotation? 180 degrees? Well, for you guys, it's like this. Ugh. So let's write down B's coordinates. B is 1, 2, 3, 4, 5, 6 to the left, and 3 up. B prime is 6 to the right, and 3 down. So it doesn't say the rule here. I don't know why that got deleted. So write this in. Sorry for that. I think I tried to delete it on the next 3, and I accidentally deleted it on this 3 as well. So what happened here? The -6 became a +6, and the 3 became a -3. Alex?
Both X and Y would seem.
Yeah, so we took X and Y, and they're the same numbers, but we changed their signs. Now remember, negation means change the sign. It doesn't mean make it negative. That negative 6 was already negative. So when we negated it, it became positive. We cool with that? Negative 6 negated is positive 6. Then we negated 3 and became negative 3. I think that last one's a little more obvious. That's the rule. That's going to be true for all of them. Now, why is that the case? Well, we started in this quadrant, right? That's negative x and positive y, right? We go to the left and then up. Well, we ended up in this quadrant. Isn't that positive, negative? Do you see how the x's change and the y's change? They change signs. Both of them do, don't they? So whatever you had before, you're going to do the opposite later. Yes? Yes, for this one you're going to have to. Yeah. So again, looking at what I got, that's the rule. Change both the signs. Why is that the case? Because whenever you rotate something 180 degrees, it does change both the signs. Look up here. Let's draw a new one. Here's my coordinate plane. Any dot I place in here is going to be a positive number, negative number, correct? Any dot I place up here, double positive, like 3, 4. Any dot I place down here would be double negative. Smell what I'm stepping in? Okay. So let's pick a quadrant, either quadrant number 1, quadrant number 2, quadrant number 3, or quadrant number 4. Ivy, which quadrant do you want to pick? Okay? So let's put a dot there. Whatever that dot's coordinates is, it's going to be positive something, negative something, right? If I rotate that 180 degrees, it's going to end up in quadrant 2. Everybody seeing that rotation, 180? Now, notice we went from positive negative to negative positive. You see how both of the signs changed? The x value changed and the y value changed. So our rule would be, whatever you started with, change both the signs. Remember, negation means change the sign. Now what if I had chosen a different quadrant? If I choose quadrant 1, it's going to end up in what quadrant after I do 180? What quadrant it's going to end up in? Quadrant 3, this one. Notice the signs both changed. Doesn't matter what quadrant I start in, the rule will always be whatever you got, change both the signs. If I start in this quadrant, both negative. 180, now we're here. Change both the signs, right? So that's the rule for a 180 degree rotation. So there's a rule. Change both the signs. Let's take a look at number 9. Again, we're centered about the origin. Let's rotate 1 point. Which point do you want to rotate? B, C, or A? B? Okay. So if I rotate it, there's my L. R is pointing to your left, right? The blue part pointing to your left. If I rotate that 90 degrees clockwise for you is this direction. So if I'm pointing this way to your left and I go 90 degrees clockwise, which way am I pointing now? Up. So that blue line is going to point up after going clockwise, and that makes sense. Clockwise is that direction, right? So we're going to go 3 up. Look at the red line. It's pointing up. I'm going to go clockwise. Clockwise for you guys is this direction. So I was pointing up, and now I'm pointing to the what? To the right. So that red line, 3 in length, is now going to point to the right 3. And there's B prime. Let's write down our coordinates. Regular B was negative 3, 3. B prime is 3, 3. Let's do another one before we assume the rule, because right now it looks like just change one of the signs, right? That's what it looks like. That can be misleading. We have all the same numbers. What if they switch spots? We wouldn't know it. So let's do C. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So C's coordinates are negative 7, positive 3. Let's rotate that L. Blue line is pointing to your left. After I rotate it 90 degrees clockwise, which way is it pointing? up, right? Same as this other blue line we had earlier. And it's going to go 7 up. 1, 2, 3, 4, 5, 6, 7. Just a longer version of the blue line we had earlier. That red line pointing up, if I turn it 90 degrees clockwise, that's this way for you guys. And now it's going to point to the right. So that red line is going to turn and point to the right 3. So there's C prime. C prime's coordinates are 3 to the right and 7 up. Oh man, it wasn't just a sign change, was it? Look at C. Here's our rule. Didn't they flip? What happened? Yes. So see how our x is -7 and our y is 3? See how they change spots? So the y goes here now and the x goes there. But that's not all that happened. See how the -7, that was our x, became a +7? So this one's sign changed. How do we write a sign change? Put a negative sign, right? That means negate it. See how this one changed? The -7 became a +7? So this one is the one that gets the negative sign. Again, another example of a negative doesn't always mean it's going to make it a negative, right? When you negate something, it means just change the sign. Made it a +7. Mm-hmm. 8 has the same rule because it's the same kind of rotation. They're both 90 degrees clockwise, aren't they? And they're both centered on the origin. Okay. So the rule for both should be flip them and negate the second guy. Let's check that. A and B are on the line. That's going to be some weird coordinates, so I'm just going to do C first. C is 6 for the blue and 2 for the red. Look at that blue line. We're doing 90 degree clockwise. Blue line's pointing this way. If I do clockwise for you guys is this way. Which direction is that blue line going to point now? Down. So it's going to be 6 down. Red line's already pointing down. If I go 90 degrees clockwise, for you guys that's this way. Which direction is it going to point now? To the left. So that red line's pointing to the left too. That makes sense. You can see that leg right there. It's like kicking a ball, swinging down. So the red should point to the left. And there's C prime. Let's check those coordinates. C is 6 to the right and 2 down. C prime is 2 to the left and 6 down. I bet a lot of you guys said it was -6, -2. I almost did that time too. Make sure you count your x part first and then your y part when you're finding that coordinate. Don't count this first. That's the y part. So see how they flipped? And one of them changed. The 6 became a -6. How do we feel about number 8? Check your coordinates. Make sure you did -2, -6 to get C prime. Feeling good? Feeling good? Feeling good? Last page. Same stuff, except we're not going about the origin. Yeah, I did delete the wrong rule. So cross out the rule for number 10, 11, and 12. We're not going to worry about that. My bad. I crossed it off, or deleted it from the wrong page. Let's do number 10. R isn't on the origin anymore. No big deal. All we do is draw our L from wherever R is. Let's do B first. Blue line's pointing this way. If I go 90 degrees counterclockwise, that's the opposite way a clock goes. For you guys, that's this way. So if I go 90 degree counterclockwise, which direction is that blue line going to point now? Doc?
What?
Blue line pointing this way. 90 degrees counterclockwise, where's it pointing now?
No.
Thank you. So that blue line is going to go down. It's 1, 2, 3, 4, 5 in length. Red line pointing up, 90 degrees counterclockwise. That's this way for you guys. Which direction is that pointing now? Left. So the red line's going to point to the left. Still 4 in length. And there's your B prime. You need to do that for all your points, but I only have time to do it for these. B is 1, 2, 3, 4, 5, 6 to the left and 3 up. Make sure you're counting from the origin. Don't count from R. Count from the origin when you're doing your coordinates. Very common mistake. Start here. 6 to the left, 3 up. B prime. 1, 2, 3, 4, 5 to the left, and 1, 2, 3, 4, 5, 6 down. How do you feel? Feeling good? And do that for all of them, all the points. Notice on number 11, when you're drawing your L for C, there isn't going to be an L, is there? That's all you've got. So when you rotate that, you're just going to rotate that line 180 degrees counterclockwise. Doesn't matter what direction you go if you're 180, right? So 180 is going to flip it around to here. 1, 2, 3, 4, 5, 6 in length. There's where C prime is going to go. How you feel? Write those coordinates down. Don't have to worry about the rule on these ones. What can I help you with before we take our quiz tomorrow? You want to talk about translations more on the first page, talk about reflections more on the second page, or any of the rotations on page 3 or 4? Feeling good? Eads, what is it? Say again? That's for a grade. I want to give you a grade, even though it has the answer key. So if you want to, just copy the answer key, or use it as practice for tomorrow. But I'd rather give you the grade than not. Just gave you? That's for a grade. Worksheet, yep. Tuesday, yeah. Always due on quiz day, right? Tomorrow you will have a reflection to do. Not like these, I mean like the written stuff, right? On Google Class. Make sure you get that done. It is 10% of your grade, a whole letter grade, right? Boost it. Some of you guys haven't done a reflection yet this semester. Tucker, right? So if you do them, there you go. If you do them now, great. Then I got to remember to go back and look for your name individually. Yeah. You need a pass? No. All right, Tucker. Yeah, I know. I know. Just put it back on the table. I'll figure it out.
Why can't I retake my quiz?
Are you ready to retake it? Did you meet with me to talk about it?
I was before I got sick.
So you didn't. I got to do that first, and then you can retake it. Well, you started already?
Yeah, we were doing it together because I already knew I failed it.
So we already did review it a little bit? All right, come back in. We'll review it after break, or either tomorrow or something, and then we'll try to take it whenever.
That's what I want to come in here during homeroom to do it.
You can try that. I don't know how much time it'll be, but you can try it. Okay? Can't hurt. It's better than what? Whose homeroom are you in right now?
Howard. I think
Okay.
I don't know who that is.
Well, even if I don't get to you down here, which is a possibility, because there's going to be a million people down here, my homeroom you can talk in. So I don't know if that's different than Howard's or not.
No.
What I'm trying to say is I apologize for not being able to get to you ahead of time.
So like
Hopefully it
I just
makes
come
up
down
for it.
here and like review it.
Yeah, yeah. If I have time, if I'm able to get to you, then great. And if I can't, well, no big deal. Just sitting in homeroom, right? That's what you're going to do anyway. Let's be honest.
And get yelled at.
Well, you no way. Let me see if I can find a clip from Patch Adams. I'm going to show you Corinne. Everybody, tell me if I'm wrong. This is Corinne.
Young. Do you have a nation
HDMI in here? Like in the Promethean board?
Oh man, I'm not gonna be able to find a clip with her in it.
Where think you're going, Tucker?
Yeah.
Oh, you didn't ask. That's a detention.
What are you doing, Tucker?
He's already long gone. Think we should give him detention.
Probably.
At the very least, he's slide him in the head.
You gotta lay the phone down.
That's a good one.
Introducing the Capital One Walmart Rewards Card. Earn unlimited 5% back on everything you buy at Walmart online.
What's in your wallet?
My father died when I was.
Yeah.
Right in your yard, buddy. I know, I'm chicken hunting.
Really? Where at?
Right there.
We're back here? No, I haven't got it.
I might get your grandma's dogs.
My grandma's dogs will devour you alive.
Not even chicken.
Where you going, Tucker? I think I'm gonna go find it. Chris.
Man,
Sorry.
he doesn't ask
She's
to
your
go
doppelganger.
anywhere.
The man went up, didn't he?
Tucker doesn't ask you to go anywhere, does he?
No, he doesn't. That's why he's always in detention. Terrible kid. 0 out of 10 would not pass.
Is it like an organic store?
He didn't pass 7th grade.
It's got a lot of that stuff, yeah, which is all right. Most of it's for suckers. Some of it matters. Organic oranges and all that. Unnecessary.